This is a severe weather risk evaluation for February 23rd, 2019. The SPC has issued a moderate risk in northern Mississippi, southwestern Tennessee, and northwestern Alabama, including the cities of Florence and Tupelo, and almost the cities of Jackson, Memphis, and Greenville. Looking at the factors contributing to destabilization, the warm front has shifted northward today. Initially during the nocturnal hours, it had been stationary. Today what we are observing is diminished cloud cover, and so enhanced insulation across much of central and northern Missouri, Alabama, and northern Louisiana. Another significant factor contributing to destabilization is strong moisture advection, as shown here at 850 millibars. 25 meters per second moisture transport across much of the area, owing to an intensification of low-level flow south of the warm front. This will lead to moderate amounts of surface-based CAPE, shown here already on the mesomanalysis, 2,000 joules per kilogram. The rapid refresh model depicts even higher amounts developing later in the afternoon, with high values coming into this area, the moderate risk area, coinciding with the intensification of mid and low-level flow fields, which will yield effective bulk shear in excess of 50 knots, most likely. And during the evening, an intensification of low-level flow and enlargement of length and curvature of hodographs, leading to enhanced amounts of storm relative velocity, which should be on the order of 300 to perhaps 400 meters squared per second squared. This should lead to an environment that is favorable for prefrontal supercells, if not supercells, along the cold front. The main feature that we're going to be looking for is a strong baroclinic boundary moving into the region later today. Ahead of that, positive vorticity advection could lead to the development of discrete convection outside of linear storms. And given the magnitude of mid and upper level flow, supercells and tornadoes will likely be moving very quickly. And the latest SPC update, which has just come in, maintains a moderate risk for the area, and we see that it is relatively devoid of precipitation. Cloud cover is still present, but it's thinning. So now looking at specific models, the NAM, which usually represents the upper end of a severe weather risk, shows this kind of structure, and a few important things to note. A nearly saturated effective inflow layer and boundary layer with, based on this model, a fairly large positive area. That is a terrible drawing. You would also note very low and very close LCL and LFC heights due to the lack of insulation, and thus high relative humidity, low condensation pressure deficit through the area. Very large effective storm relative velocity, which is further demonstrated by the forecast sounding up here in the upper corner. Very large and long looping hodographs. Low-level flow is backed favorably with vertical extent, and the environment should be favorable for the development of supercells. These supercells could be capable of producing strong long-track tornadoes, in addition to damaging winds and large hail. This has been a severe weather risk evaluation for February 23rd, 2019.